Many of you would have heard the term cross Yagi in discussions among amateur radio satellite communication enthusiasts. A cross Yagi is nothing but two normal Yagi Uda antennas mounted on the same boom, rotated 90 degrees in position. Cross Yagi is used for EMA, Earth Moon Earth, or moon bounds, in addition to satellite communications. In all these modes, the signal has to cross the ionosphere, which can cause unpredictable polarization rotations. Circular polarization is used to reduce losses in such a scenario. Most of the antennas which radio amateurs use on HF, VHF, UHF bands have linear polarization, either vertical or horizontal, and are not ideal for satellite communications. Polarization of an antenna is the direction of electric field produced by the antenna and determines the direction of transmission and reception. In circular polarization, the radio waves rotate as the signal propagates. If it rotates to the right, it is known as right-hand circular polarization, RHCP, and if it rotates to the left, as left-hand circular polarization, LHCP. Using circularly polarized antennas helps to minimize the effects of cross-polarization losses as the satellite moves through space. Even if the satellite antenna is vertically polarized, the signal changes direction as the satellite tumbles and spins in orbit. Cross-polarization means polarization of the transmitting antenna and receiving antenna are at right angles to each other, producing great signal loss near to total in ideal conditions. If your antenna is circularly polarized, the signal loss will not be total when the satellite tumbles and spins in orbit. Difference in signals received between right and left hand circular polarization will be only 3 dB, unlike that between horizontal and vertical polarizations, which could be near total loss of signal regardless of how much power is used. Two types of arrangements of cross-Yagi elements on the mast has been described. In X setup, both sets of elements are at 45 degrees to the ground so that it will look like an X. The other setup is plus or cross setup, in which the elements are at 0 degrees and 90 degrees to the ground so that they will resemble the plus sign. In the plus or cross setup, the mast must be of non-conductive material to prevent strong negative influence on the vertical elements. If both dipoles are driven by one signal with different phasing, circular polarization results. X position is usually used for circular polarization. In the plus or cross setup, it can be used as two antennas, one with horizontal polarization and another with vertical polarization. If remote switching between the positions on either limb is needed from the shack, two sets of cables have to be used. For non-switchable circular polarization, cables of different lengths united over a 3 dB coupler splitter can be used. An option for maximum flexibility is to have a polarization remote switch on the antenna. Two cables go to the antenna from remote polarization switch and one coax and a control cable go to the radio. Remote polarization switch permits switching between left or right hand circular polarization as well as between horizontal and vertical linear polarization. So multiple options are available if you use a polarization remote switch at the antenna location of a cross Yagi. Circular polarization is produced by two linearly polarized orthogonal signals of equal amplitude which are 90 degrees out of phase. As antennas with same geometry will have same output radiation for the same input, if two linearly polarized antennas of same geometry are placed at 90 degrees to each other and fed with 90 degrees phase shifted input, output will have circular polarization. This is the principle of cross Yagi. Phase shift of 90 degrees can be achieved by using an additional cable of quarter wavelength, taking into consideration the velocity factor of the cable as well in the calculation of quarter wavelength. Phase difference occurs due to the extra transmission time in the added cable length, one full wavelength of a sine wave being 360 degrees.